Ran out of time last time right here in the middle of what we were doing. Conditional probability problems. Probably as a first step, you're going to realize you can work out conditional probabilities with that formula that you have on your formula sheet. And then as you do that more and more, you might come to realize why this formula works. Okay, I don't know if we have a picture back here somewhere. No, well, we'll do one later here, and it'll make some sense. We were in the middle of doing this. You have two factories. 70% of the product comes from one, 30% comes from the other. So we made this probability diagram, tree diagram, 70%, 30%. And then it gives you some information about within factory one. So once you're there, the chance of it being defective. Defective given its factory number one is 25%, and that means that, not that we need this number, but I put it down there, the chance of it not being defective given you're in number one is 75%. And then the other part of that they say is 10% of the chips in factory two are defective, so chance of being defective given you're in factory number two is 10%. If you work out what these numbers are, there's kind of two quite different numbers here. Like up here it says 25% of the factory one chips are defective and 10% of the factory two chips. Those numbers seem fairly, I mean, one's obviously bigger, but not that much bigger. When you look at this factory, of all the defective ones you're looking at, like a big majority come from factory number one. Now, why is that if you look at the numbers? It looks like they had produced 10% of 10% of theirs are defective, 25% of theirs are defective, but factory one produces way more of them. So that's why the numbers end up being so lopsided. The first question that we answered last time was, what's the chance of it being defective, just overall? Well, you have to multiply it out and look at all the possibilities here. I think it would help if we put in these other two percentages, even though we don't need them. Like the ones that we're adding up here are, it could come from number one and be defective, so this number up here. Or it could come from number two and be defective, that one. And then I think it would help to do these other numbers. So can somebody tell me what this one, I guess, is, what is that? 27%? And what's this one right here? 70% of 75%. 0.7 times 0.75. Somebody real quick on the calculator? Should I pause? What is it? Okay, so that's all the possibilities. The defective ones are these two together, which is what we did up here. The non-defective ones are the other ones. If you added those up, that's all the non-defective ones. That'd be the probability of not being defective. The other two should add up to what, the leftover part here, 79.5%, right? Which I think they do if you look at that. 79.5%, because it's the complement of that. The second part of this here, though, is asking, suppose a defective chip is discovered. What's the chance it came from factory one? So this would be kind of like if you took all of these and lumped them all together in wherever the warehouse is that they're putting these things. If you pull one out at random there, what's the chance it came from factory one? Hi. If you took all of that and lumped it all into the big warehouse at the end, so here's all the chips, what's the chance, if you happen to find a defective one out of here but you don't know where it came from, what's the chance it came from factory one? Once you've pulled a defective chip out of there, which part of this do you know it cannot be? Yeah, it can't be that and it can't be that, so the total is not 100% anymore. The total is now only how much? 20.5. So out of 20.5%, what fraction of that are the ones that came from number one? 17.5, right? It's not 17.5 out of the whole thing anymore. It's 17.5 out of just the ones that are defective, because it says we know it's defective, so it can't be the other ones. It's reducing the sample space down from all of the things, all the possibilities, down to just the ones that are defective. That's why you can divide two probabilities here. You're taking this fraction out of the other fraction, right? Like this percentage out of that smaller percentage. What does that give you when you divide those two numbers? 80 something? So let's call it 85.4, I guess. So 85% of the defective chips come from factory number 1. Right? 85% of the defective chips. 17.5% of the chips are defective and come from number 1. Like 17.5% of all of the chips. This is saying 85% of the defective ones. You're just doing that percentage out of the ones that are defective. That's all conditional probability is reducing the sample space down. Okay? I think there's another question later on here that's going to help your understanding of this. Is there any questions about that one, though? I know at the risk of, well, I won't again, but the classic question for this is this disease one, because in this factory question, probably, if you have this warehouse, there's some stamp on the chips or whatever, and it says which factory it came from somehow. There's a code on it or whatever. So you would actually know, and you wouldn't necessarily care about that. This happens first, and this happens second, the defective or not. But, once you discover this, what's the chance of it being number 1 there? The disease thing, when you start to look at that question, you might be able to make some sense of it. This is a dumb question. You can go through and do it, I don't know what I was thinking, but you can go through and do it using tree diagram and all that. You'll just discover that it ends up being, like it says, what's the chance that the second card drawn is a king? You could make a tree diagram and say, well, the first card could be a king or not a king. Second card could be. In the end, you find what's the chance the second card is a king? It's 4 out of 52, right? Because you know nothing about the first card. Anyways, let's not do that. I don't think you're going to gain any understanding by doing that one. I actually meant to take it out. This one I think is going to be better because there's a visual here that you can use. Can you try and fill out each of these probabilities? When you start to do these conditional things, you can use the formula, right? Remember, I keep talking about this formula. If you're not sure, I mean this, right? This formula right here. Probability of A given B. Think about what we just looked at with the 20.5%. A given B. Given B has happened, you need all the ways B can happen. And then you need to look at the portion of that where A also happens, right? It's like all the ways B can happen and all the ways A can also happen with that, okay? No, go outside and try again, okay? Go, really. Blooper reel. Whether you're approaching this using this formula or whether you're just understanding kind of from the visual point of view, or when you look at this thing, if you're figuring out these just by reducing the sample space down, can you try and write down some of those? I think I said that a second ago. Write down those probabilities and we'll check in a second here.